today we will discuss about the liquid drop model of the nucleus. This is in continuation of the previous lecture, of modern physics, paper 9, semester 4, physics honors. So here what we know is that Bohr and Sommerfeld, okay, their atomic model based on experimental observation, it indicates, now this indicates what, that the atom consists of central nucleus. Okay, it consists of central nucleus containing entire positive charge and almost whole mass of an atom. So the nucleus, it seems to be surrounded by a cloud of revolving electrons having net negative charge equal to positive charge of the nucleus, so that the atom is electrically neutral. Now, to explain all this fact, to explain this particular fact and the nuclear forces, attempts have been made to give a nuclear model, and various models have been proposed since 1932, okay, to serve the purpose. But then what we need to discuss today is only about the liquid drop model. So liquid drop model, basically it's it is again been suggested by Bohr, actually, that the nucleus might be like a he suggested, Bohr suggested that the nucleus might be like a droplet of dense liquid, okay, composed of the subdroplets of the proton and neutrons. Okay, now this picture of nucleus, it is very much analogous to the macroscopic picture of a small water droplet composed of molecules. Okay, now it has been observed that except for light nuclei, the binding energy per nucleon remain almost constant. So it is very much obvious, that is, the total binding energy varies linearly with the number of nucleons, okay, nucleons, capital A, in the nucleus. Now the same is true for the volume of the nucleus also, okay, which gives the dependence of nuclear radius, as we already have this particular relation, R is proportional to e to the power 1 by 3. So there has been certain analogies. Okay, there are certain analogies between atomic nucleus and a small drop of a liquid that support the liquid drop model of the nucleus. So analogy which support atomic nucleus in the form of a liquid drop model. Okay. Maybe given or maybe summarized as number 1. Say the small drop. Number 1 is that the small liquid drop, the small liquid drop, okay, is spherical. Okay, that we know because of surface tension. That we know. And the atomic nucleus is assumed to be spherical. Right? Number 2 is, so this is the analogy on which this particular theory has been proposed by Bohr in 1936. Number 2 is the density, okay, the density of a spherical liquid is independent of its volume, of its volume, right? This is also true for atomic nucleus. This is also true for atomic nucleus. Okay, now this in this analogy there is a disparity. Now disparity in the sense that the density of liquid depends on the type of liquid. Okay, density of the liquid depends on the type of the liquid, whereas the density of the nuclear matter is independent of the type of the nucleus. Okay, so this we may take an example and do it of your own. Okay, then finally number third point, we'll come to the third point, that is the molecule in a liquid drop, okay, interact over short ranges as compared to the diameter of the drop. That is, they interact only with the immediate neighbors. Okay, and similarly you can write the nucleon in a nucleus, okay, interact with their immediate neighbor, right? So these are the similarities, or you can say the analogy between the nucleus structure and liquid drop model. Okay, number 4 is the surface tension. Okay, the surface tension forces acting at the surface of the drop. Okay, acting at the surface of the drop are analogous to the potential barrier effects at the surface. This is the point number 4. Point number 5 is the molecule in the drop move over short distance with thermal velocity. The molecules in the drop move over short distance with thermal velocities. Okay, if the temperature is increased, to increase the thermal agitation, the evaporation of molecule will take place. Similarly, the nucleus possesses definite kinetic energy within the nucleus. Okay, if the energy is given to the nucleus by the bombardment of light particle, a compound nucleus is formed which emit nucleus almost immediately. Then number 6 is, if a liquid drop is made to oscillate, okay, it tends to separate into two parts, okay, of equal size, right? Similarly, certain heavy nuclei also break into lighter fragments after capturing neutrons. Okay, that is nuclear fission we are talking about. Number 7 is the existence of non-zero quadruple moments shows that many nuclei are non-spheric. Okay, this phenomena can be described well within the framework of the liquid drop model by allowing the drop to be a non-spherical shape. Okay. So the liquid drop model has been utilized with a certain amount of success in the interpretation of internal nuclear forces and nuclear fusion phenomena. But it could not explain this particular model. It could not explain why number of proton Z and number of electron N are equal for lighter nuclei with N somewhat larger in heavy nuclei. Further, according to this particular model, a nucleus is more tightly bound and more stable. Okay, now if it contains more neutrons and the fewer protons, because this would reduce the mutual repulsion of the proton. Further, the model could not explain why there is no helium isotope or oxygen isotope which contain greater fraction of neutrons than the actual present isotope. But still, these are the demerits or the shortcoming of this liquid drop model. These are the things on which the liquid drop model has been assumed to be working out. Okay. So in the next class, we will discuss about the semi-empirical mass formula. Until then, thank you.